Okay, here's section 5.1. It is all about solving systems of equations. And basically 5.1 is about graphing them. You're going to be solving systems of equations all throughout chapter 5. What that means is it's just a fancy word for finding out where two lines intersect. So the solution to a system is where two lines intersect or they run into each other. So you're looking for a point. So go ahead and write these targets down. You might want to pause the video. So the first thing I want to teach you is how to identify them. So if I give you a point, let me write example number 1 here. Look at that perfect box. Well, almost perfect. Oh, my hand keeps hitting pause. If I give you the point 4, 1, and I give you two equations, and I'm going to use a little set symbol because we're using two equations. And the first equation is x plus 2y equals 6. And the second equation is x minus y equals 3. If I was to ask you if this 4, 1 was a point on both of these lines, then these are linear because you can see they're in standard form. So if I graph them, they would be lines. What I'm asking is if I graph these two lines, would they both have 4, 1 as a point on both lines? Well, if it's going to have 4, 1 as a point on both lines, it's got to be where it crisscrosses. And if 4, 1 is truly a point, then I should be able to plug it into both equations and it should work. So I'm going to take the top and I'm going to plug 4, 1 into it. So I'm going to do that over here. So I'm going to remember the 4 is an x and the 1 is a y. So I'm going to replace it with the values. My pen is not working very good. That's 2 times 1 equals 6. So if I go ahead and multiply that out, I get 4 plus 2 times 1 is 2 equals 6. And I'm going to change to my finger. And 6 equals 6. So yes, that one works. But if it's a solution to the system, then it should work for both. So I'm going to try the red one. And I'm going to put a 4 in for the x and a 1 in for the y and see if it really does make 3. And it does. So yes, the point 4, 1 is a solution to the systems of equations. I'm going to keep repeating that big, huge sentence, solution to the systems of equations. But you might want to write in your notes a little bubble that says this means just finding where the two lines intersect. Hey, there's my alarm. So every time you're looking for the answer to the two systems. So let me let you try one. Or actually we can try these together. But so here's another example. If I give you -1 and 2, and the system that I give you, the two equations that I give you, is 2x plus 5y equals 8, and -2y equals 5 minus 3x. Notice that I did not give them both to you in standard. They don't always have to be in standard. They can be in any form. All you're doing is trying to figure out is -1, 2 on both lines. So if it's on both lines, then it will be true for both of them. So we go through that again. So go ahead and pause the video and try to plug these in. So here I changed the top one to a purple, just so that it's easier to see the difference. So -1, 2 did work for the purple. You can see that right here. So that means that -2 is a point, -1, 2 is a point on that line if I if I graphed that purple equation, it would make a line, and negative 1, 2 is a point on it. If I graphed the second equation, the red one, you can see that negative 1, 2 is not a point on the line because it doesn't make the equation true. So it's a point somewhere on the graph, that like the ordered, the coordinate system, but it's not sitting on the red line. So no, this is not a solution to the systems of equation. And you can write that. It's hard to write with my finger. So write no, this is not a solution to the systems of equations because it has to be true for both lines. Go ahead and pause the video. Okay, so I'll give you one more example that you can try on your own. So the directions are the same. I'm trying to figure out if this is a solution to the systems of equations. And the equations that I'm going to give you are 2x plus y equals 5 and negative 2x plus y equals 1. So go ahead and try that on your own. Pause the video and then I will give you the answer when you come back. So you should have gotten yes on this if I plug this in. 2 times 1 plus 3, and I get 5 equals 5, which yes, that is a point on that line, so I try it on the red line, and negative 2 times 1 plus 3, and I get 1 equals 1. So yes, 1, 3, the point 1, 3 is a solution to the systems of equations. Okay, so now we've hit target 1. So target 2 was, can you identify it from a graph? And that's pretty easy too. Let me turn on some graph paper here. So, solving a system. By graphing. So we've done it algebraically, and now we're going to do it graphically. So I'm going to go to a new screen just because I know it's going to take a lot of space up for me on this thing. You're going to be given two equations. So you have y equals 1/3 x minus 3 and 2x plus y equals 4. So what you're going to want to do is graph these. So let me try to make my x and y here. See if I can make it semi-straight. Okay, so how do I graph equations? Well, there's a lot of ways we've been learning. You could make a table. You could do it by x and y intercepts. You could do it by slope and y-intercept. You could, I guess that's it, point and slope. So the first one, the red one, is already in what kind of form? What form is that in? You should have said slope, intercept. So I'm not gonna make a table. I don't like making tables. I would rather pull the slope out of it, which is 1/3, and the y-intercept, which is -3. So I'm going to go down 3, put my put my y-intercept. I'm going to go up 1 over 3, up 1 over 1, 2, 3, down 1, back 3, down 1, back 3. So there's my line. Let me see if I can make a line with this. Can I make a line? Oh, look at that. Alright. And we have arrows, and I should have crossed over the axes. There we go. So that's going to be the red line. So now I'm going to go to the purple one. The purple one looks like it's in standard form. I could alternate it, and I could move the 2x over to the right so that it's in slope-intercept form and do it the same way that I did the red line, or I can do the cover method and just go by x and y intercepts. So I'm going to draw a line down here. So my x-intercept, if I cover that plus y, because every time my line crosses x-intercept, the y is 0, so I'm going to pretend that's 0, and I solve for x, I get 2. So my x-intercept is 2, 0, and my y-intercept, if I now cover this one and solve, I get y equals 4, so I know it's 0, 4. This is review, so if this is not familiar to you, hopefully you did okay on the test from last chapter. So I'm going to go ahead and do my x-intercept, which is 2, and my y-intercept, which is 4, and make a line with this nifty-difty line function thing. Let's see if I can make one. This is hard. Okay, so pretend like this keeps going. I'm afraid if I move it up there I won't get it straight. But you'll be able to do it much better with a ruler. So you'd better be using rulers or a straight edge of some sort, the edge of your paper, the edge of your cell phone. I don't care what you're using, but you better be using something that's straight, because this accuracy is going to count. Because if you're a little off, you're going to not have the correct answer. You can see, I know yellow doesn't show up really good, but can you see right here where the two lines crossed? If I was to ask you to write that ordered pair, then that ordered pair would be 3, negative 2. So the solution, or the answer to the system, is 3, negative 2, because it's where those two lines intersect. It's a point that they share. So if I still wasn't convinced that this was right, and maybe you're arguing with the person next to you and you're like, no, I don't think that 3, negative 2 is right, you didn't use your ruler, you don't have the right angle, or you're off one, or you didn't count right, this point should work for both equations. It is the only point that's ever going to work for both, because it's the only point that they share if you look on the line. So you could plug those in just like we did in Target 1, in the Objective 1 that we were just doing on the previous screens. You could plug it in and see if 3, negative 2 actually works. If it works, then you know you have it right. But you don't have to do that every time. So that's how you solve a system graphically, is you graph it and look for where it crosses. Okay? Okay, one more thing, real life application. So Damon wanted to be in one of the videos, so you're there now. Your daycare charges $2 a pet, $2 a kitty, and $2.50 an hour. Levi, you should remember this, because this was in my notes from last year. We said it was your poop bowl. I don't know why. It was like a bowling alley or something. But Levi's lovely daycare charges $4 pet and $2 an hour. The question is, for how many hours will it cost be the same? for both companies. Oh my gosh, my finger's getting a cramp in it. I really need to get a pen. Okay, so really you're looking for where both companies cost the same, and we've kind of done that earlier in the year. You're looking for, we did it with inequalities, and we looked for when does one company override the other one, when does one company cost more than the other one. So it's kind of that same thing, but we're looking for that point where they're exactly the same. So we want to write equations to these. So think about an equation. You might want to pause this and talk about it as a class. What equation could you write for Damon? What equation could you write for Levi? So Damon's equation should be y equals 250x plus 2, because the 250 is happening over and over and over. Levi's should be y equals 2x plus 4. So let me put those equations onto the next screen. Okay, and let me add some graph paper. So later this week you're going to learn how to solve these algebraically. But right now the only way you know how to deal with it algebraically is if I give you a point, you can tell me if the point is a solution or not, but you don't know how to find that point unless you're graphing it. So it's all about the graphing today. Okay, so I'm going to go ahead and make my graph. Wow, did you see how straight that? Oh, I was doing good for a while there. That line was pretty straight. I know I'm going to need some space up above. That's an arrow. Okay, so I'm going to graph Damon's. So it's they're in slope-intercept, so I'm just going to go ahead and use slope-intercept. The y-intercept is 2, and the slope is 250. So if you think about 250, actually I should write this right here. The y-intercept we said was 0, 2. The slope of 250 is 2.5, and that just doesn't make sense. That's going to be hard to think about. 2.5 over 1. Go up 2.5 over 1. So I'm going to turn that into a fraction. 2.5 is the same thing as 5 over 2. That's going to allow me just to go ahead, there we go, and go up 5 and over 2. That's way easier than trying to deal with halves. So 1, 2, 3, 4, 5, 1, 2. 1, 2, 3, 4, 5, 1, 2. Let me erase those little jobbies there. Okay, and I'm going to connect it. Remember, this is, can I move that line? No. Shoot, that was a bad connection. Let me try that again. You want to make sure that you are using your ruler. This is hard for me because I have to put it down right exactly at the right spot. So now if I solve Levi's, you can see that the slope is 2, the y-intercept is 0, 4, so 1, 2, 3, 4, up 2 over 1, whoops, up 2 over 1, up 2 over 1, up 2 over 1, okay, and then you can see, mine's not going to turn out very good. Yours is probably way better because you're skinnier pencil and well, I'm just going to draw it. Okay, so you can see that they would have connected right here. So that solution, this is why you want to use pencil and be careful. Mine's too thick. So that solution would have been 412. So I can check to see if that's accurate. If I plug 412 into Damon's equation, then 4 times 250 is 8, 9, 10 is $10 plus 2 is 12. If I plug it into Levi's equation, 4 times 2 is 8, and 8 plus 4 is 12. So I know 412 is the answer. This is a story problem, so you don't just want to say, oh, the answer is 412. The 4, the x, what is the x? The x is how many hours, and the 12 is the cost. So then your answer is, at 4 hours, and I'm not going to write with this pen. You write it down. I'm not going to write it, but you would put, after 4 hours, it will cost the same $12 no matter which company you choose. So that's how the application problems go. So you can go ahead and work on your assignment. Tomorrow I will show a video, and I don't know if you'll have time to get through the whole video tomorrow, so you might just have to write down the link and do it from home, or you can read the book if you don't have the internet. You can read the book for tomorrow's assignment, but unfortunately I can't not give it. You'll have 2 weeks to look at it and try and figure it out, and like I said, I'll make a video for it, and then you can copy down the link. So have a good day.